Hello, Mr. Scott here again. This is the second video in regards to that review booklet I gave you guys. This one I'm going to promise, I don't know if you saw the first one. The first one was crazy long. I want to keep this one a lot shorter, so it's not going to be quite as much explanation as I would have done in another video, but I still want to have all the questions answered, so at least you guys have a resource. One thing I always want to start each of these videos with, just a reminder, if you have not done these questions yet, I would not suggest watching this video. You really should be trying these questions on your own before you actually watch this, because I want you to actually get some practice here with them. But if you've tried them, if you're stuck, then that's what this video is for, or if you just want to check your answers, that's what it's all about. Anyways, question number 1. Sketch the angle and name its reference angle, 240 degrees, or 242 degrees, sorry. If we're going to sketch that, first of all, let's just remember our quadrants are kind of like such. This is 90 degrees up here, this is 180, this is 270, and that brings us back to 360 or 0 degrees over here. If our angle's 242 degrees, that means we're going to be somewhere between these two, a little bit closer to 270, so I would say right there. And then it says name its reference angle. Well, a reference angle is just between the terminal arm and your nearest x-axis. So this right here, that angle right there is going to be our reference angle. So it's going to be between, or the angle between this line right here and 270. So it's going to be our 242, yeah, just double checking. 242 degrees is this angle here. Pretty much it's just going to be the difference between 242 and 180. So our reference angle will be 242 minus 180, or in other words, 62 degrees. Question number 2, find the exact value of the following without using a calculator. Whenever you see exact value and without using a calculator, you should be thinking on your formula sheet to your special triangles, which I've provided for you. They're right on the bottom, so we're going to have to use them. So, cosine 210, if you imagine on your grid, 210 degrees, that'd be about right here. That means we have a reference angle. If this is 180 and that's 210, our reference angle would be 30 degrees. Now just a reminder, cosine is, well, think SOHCAHTOA, so it would be adjacent over hypotenuse. So since it's adjacent over hypotenuse, if you look at your special triangles, which has a 30-degree angle in it, this one has 30 degrees down the corner, so we're going to be looking for adjacent divided by hypotenuse. So adjacent divided by hypotenuse. So in this case, cosine 210 is going to equal the adjacent side, which is root 3, divided by the hypotenuse, which is 2. So it'll be root 3 over 2. Very last thing here, though, is you have to remember, even though it says 210 degrees, you have to remember that cosine, sine, and tan are different, like positive or negative, depending on what quadrant we're in. You got to remember the CAST rule, C-A-S-T. Which means cosine is positive here, everything is positive up here, sine is positive up here, and tan is positive down here. Well, because we're dealing with cosine down here, well, cosine is not tan, so that means it's going to be negative, so we're going to have to change our answer to negative root 3 over 2. So for question 2, part B, very similar, sine 350 degrees, so 315 degrees is going to be just right here. The reference angle in this case is going to be 45 degrees, because in other words, another 45 degrees from 315 is going to get you up to 360. So we have a reference angle of 45 degrees, which is one of our special angles. So we'll go to our special triangle with a 45-degree angle in it. Since we're dealing with sine this time, it's going to be opposite. So there's our 45-degree angle. Opposite divided by hypotenuse, so it'll be 1 over root 2. So sine 315 equals 1 over root 2. But again, we have to use our CAST rule. So our CAST rule is going to say cosine is positive here, everything's positive here, sine, tan. Well, since we're dealing with sine and we're in the cosine quadrant, that means this is once again going to be negative. So our answer will be negative 1 over root 2. P, 4, negative 3 lies in the terminal arm. Determine the exact trig ratios of sine, cosine, tan. So again, if we're going to put this on our graph, we're looking at the coordinate 4, negative 3, so it'll be about 4, negative 3. Put a dot right there. Terminal arm is going to pass through that dot. We're looking for the trig ratios for that terminal arm, so we're going to pretend we have a right triangle right up here, dealing with this as our angle. Since this was 4 and this is -3, we can call that side right here, -3 is going to be the depth of this side over here. And we'll just erase that there. If we're going to look for our ratios, we can clearly see we have our opposite and our adjacent, but we're going to need our hypotenuse. So to find the hypotenuse, just use Pythagoras, which is going to say 3 squared plus 4 squared. Well, I guess -3 squared is really what it is, but it won't make a difference here. -3 squared plus 4 squared equals, well, I already solved it right in my head. Look at me go. 5 squared. It's actually going to be the answer, 5 squared, because -3, if you don't believe me, -3 squared is 9, plus 4 squared is 16. Well, that's going to equal 25, and the square root of 25 is 5. I'm just a wizard, so I knew that right off the top of my head. But hey, don't worry about it. 5 is going to be the length of the hypotenuse, so we know 5 is going to be that side right there. If we want to set up our trig ratios, let's start with sine. Sine of that angle is going to be opposite divided by hypotenuse. So opposite is -3, hypotenuse is 5. It'll be -3 over 5. Cosine is going to be the same general idea, except it's going to be 4 over 5, because it's got to be adjacent over 5. So 4 over 5. And then the last one, of course, tan. Theta is going to be opposite over adjacent. So opposite over adjacent, -3 over 4. Nice thing about this is it aligns with the cast rule, C-A-S-T. Only cosine should be positive down here, and if you look at our answer, well, only cosine's positive. So the next one, we're told sine of theta is 5 over 13, and that theta is in quadrant 2. We set up our quadrants once again. We know we have an angle. We'll say it's just right there. It's in quadrant number 2. Sine is going to be 5 over 13. Well, this is our angle right here. Sine is opposite over hypotenuse, so we know this is 5 and this is 13. Rest of the question is asking us to find what cosine and tangent would be. Well, once again, we're actually going to need to solve for this missing side here, so it's going to be 5 squared plus, we'll call this just x, so x squared equals 13 squared. Now, I'm not quite as much of a wizard on this one as I was in the other one, so we'll just solve it the longhand way. 25 plus x squared equals 13 squared, which is 169. Minus 25 on both sides is going to give us x squared equals 144. Okay, so then you square root both and it'll be x is 12. So we know the length of this one is going to be 12. Now here's the tricky thing though. Think of this as a coordinate up here. 5 is our y value because we're 5 up, whereas this right here, this 12 would be our x value. But if we want a bit of a shortcut, just so we can, go around the cast rule later on, we need to recognize that it's not just 12 here. This is leading to our x coordinate, so this should be -12, because x is going to be negative in this section over here. That'll just help us so we don't have to use the cast rule in a minute here. So again, it's looking for cosine and tan, so we can say cosine of that angle, this being our angle, up there, that's our angle. All right, so cosine of that angle is going to be adjacent over hypotenuse, so we're going to say adjacent is -12, and our hypotenuse is 13. So cosine -12 over 13. As for tangent, same general idea, except it's going to be opposite over adjacent, so 5 over -12. And if you know me well enough, I hate having a negative number in the bottom, so we're going to change that to -5 over 12. Doesn't matter where the negative number is, it's just not nice having a negative in the bottom, so you can just move it up to the top. 6, solve for theta if theta is between 0 and 360 and sine theta is -√3 over 2. Right as soon as you see that -√3, or even just √3 in general, you should be looking right at your special triangles. The only special triangles that have √3 in them are the ones that are 30, 60, 90 triangles right here, so we know we're going to be using one of those. But again, if we have a look at the question, it says solve for theta between 0 and 360, and notice that sine is going to be a negative number here. Again, if you look at the cast rule, cast rule is going to say sine is only going to be negative either here or here. So only those two quadrants is where sine is going to be negative, so we know our angle is going to be between 180 and 360 degrees. But we'll get to that in a second. Again, if we look at this special triangle here, since sine is √3 over 2, and sine is opposite over hypotenuse, then we know that √3 is going to be our opposite side, which means our angle has to be 60. If it focuses here, there we go, it has to be 60 degrees. So we know our angle is going to be 60 degrees, but remember, cast rule is saying these are the only ones where it's going to be negative, so it's not going to be 60 degrees. 60 degrees is going to be our reference angle down here and our reference angle down here. So we're going to need to take account for that. if 60 degrees is a reference angle down there, that means this here is 60, which means our actual principal angle is going to be 180 plus 60, which gives us 240 degrees. But that's just one answer. It could also very well possibly be 60 degrees in that quadrant right there, which is going to give us a principal angle of 60 degrees less than 360, which you should already know right in your head. 360 minus 60, 300 degrees. So there's two possible answers here. It's either 240 degrees or 300 degrees, and both of them are totally correct. Okay, so question 7a is asking us to find the measure of that missing side right there. With this triangle, notice we have two angles already. Anytime I see two angles in a triangle, I just want to solve for the missing side or missing angle right away, because it's going to help us one way or another, and even if it doesn't help us, well, it's not too hard to find. So we have 41 degrees and 64 degrees. So find the missing angle. Just go 180 minus 64 minus 41. And then that's going to give us a missing angle of 75 degrees. So we know this angle way down in the corner here is going to be 75 degrees. So we can use now, noticing that we have 75 degrees here and we're looking for the opposite side, we can use one of our trig laws here, either sine law on the top or cosine law on the bottom. Well, because we have opposites, we're going to definitely be using sine law, and again, this is an angle-side triangle. Or also known as an angle-side-angle triangle. So yes, sine law is going to be the one we use here. So notice x is our missing side, as long as we can refocus. X is our missing side. Sides are going to go on the top, divided by, and it's this one we're using right here, again, as long as I can refocus any second here now. We're going to be dividing by sine of the angle across from it. So dividing by sine of the angle across from x, which we just determined to be 75 degrees, and we're going to set this equal to another pair with a side on the top and the sine of its opposite angle on the bottom. Well, the only other side we know is 12, so we'll put 12 on the top, and we're going to divide it by sine of the angle across from it, so sine 64. From here, since we want to solve for x, all we have to do is just times by sine 75 on both sides. Now it's really important before we even do this, make sure your calculator is in degree mode. And if you have a TI-83, you can always check by pressing mode and then seeing that it says degree instead of radians. So definitely make sure you're in degree mode, otherwise you're going to get the wrong answer here. So all we're going to do, since we want x, go 12 divided by sine 64 and then times whatever that is by sine 65. So 12 divided by sine 64, and then times that answer directly by sine 75, and that's going to give us, you might not be able to see it on camera, but it says 12.89. So we'll just round that up to 12.9. So x is going to equal 12.9, and there are no units on that, so that's going to be our answer. X is 12.9. 7b, if you look at this one, we have two sides in the enclosed angle. In other words, we have an SAS triangle. SAS triangles, we're going to have to use cosine law. If you ever have a hard time remembering which one's which, honestly, if you just piece together your different formulas here and figure out, okay, what kind of things do I have, you should, if I get refocused here, you should be able to figure out which formula to use, just given the little pieces that you've got. If you can't, just get some practice on this or try to remember the rules and you'll be good to go. So on this triangle that we've got here, and again, my focus is very off right now, I'm not sure what's happening, but on this triangle right now we have an angle of 110 and we've got two sides that are 9 and 7, and we're missing x. This is going to be a cosine law question. Since we're missing a side, we're going to be using this equation right here. This equation over here is going to be giving us a missing angle instead. And I got a hair here that's just fallen down. Anyway, sorry. This one is definitely going to be the one we want to use because it's looking for a side. A squared is talking about a side. So a squared is going to be our x. So we're going to say x squared equals, and then it's b squared plus c squared. Those are just the other two sides. So we'll say it's 9 squared plus 7 squared minus 2 times bc, so times 9 times 7, times, I'm just going to carry on the multiplication down here because I'm running out of room, times cosine of a, cosine being that angle you have in between, which is 110 degrees. So times by cosine 110. Just take this entire thing, put it in your calculator all in one step. Just be careful with this section right here. I usually put this whole section in brackets just to make sure nothing gets messed up here. So I'll show you what I mean. We're going to go 9 squared plus 7 squared minus, in brackets, 2 times 9 times 7 times cosine 110. And then make sure your brackets are closed off. Press enter. This is going to give us x squared equals about 173. And of course we want x. We don't want x squared, so we'll square root both sides. X is going to give us square root of 173. Oops. Sorry. Square root of 173, our answer. That's going to give us 13 point, we'll round it up to 13.2. So 13.2 is going to be our x. See now, notice we only have one angle, but it's not an angle enclosed by the other two sides, the other two sides being 12 and 10. We're looking for a missing angle this time. You'd think that since this is the third question, you think this would be the hardest one. It's actually, I think, the easiest one. Notice we're looking for an angle, we have its opposite side. We have an angle and we have its opposite side. We can just use sine law here. This is just a side-side angle triangle, an SSA triangle. So we can just use sine law. We're looking for an angle, so we'll say it's sine of x divided by its opposite side, which was given to be 10, equals sine of the angle that was given, which is 65, divided by its opposite side. And remember, sine law only works as long as you have opposite pairs. So sine 65 divided by 12. And we want to rearrange now to solve for x. X is trapped in the sine function though. I'll show you what I mean. We're going to have to dig that out. Let's first though times by 10 on both sides. So we're going to go 10 times sine 65 divided by 12. So sine of x is going to equal, let's put this in the calculator, 10 times sine 65 divided by 12. Oops, lost it, sorry. 10 times sine 65 divided by 12, 0.7552. So with that now, if I wrote that in, 0.7552, we want to get x. We don't care about sine x. So we're going to have to take the inverse sine of both sides to get rid of the sine here. So if you take the inverse sine of both sides, just like that, and to do that you press second sine of 0.7552, just like that. That's going to give us 49 degrees. So x is going to equal 49 degrees. Okay, so for the last couple questions here, notice question number 8, 9, and 10 are still remaining. I'm not actually going to do question 8 or 9, and let me just quickly explain why. Question 8, solve each triangle. You have to find all the sides, all the angles. It's kind of like this last one we just did, except you have to find, well, literally all the missing sides, missing angles. You should be able to figure that one on your own, so I'm going to leave it. Question number 9, it's determining how many triangles satisfy those conditions. This is an ambiguous sine law question. Have another look back at your notes, look for ambiguous sine law. That'll cover what that question is covering, but again, it's time consuming. I'm not going to go over it. I will, however, go over question number 10. Two boats leave a dock at the same time. Angle between them is 54 degrees. One boat's 80 kilometers and the other one goes 100. We're looking for how far apart they are. A picture speaks 1,000 words here. Always draw a picture on these ones. So they're both starting from the same point. We'll say one goes this way and one goes this way. This one we'll say is the one that went 80 kilometers. This one is the one that went 100 kilometers. And remember, the angle between their courses is 54 degrees. So we'll say that is 54 degrees. The question is asking how far apart are these two boats. So this is our unknown. Since we have an angle, or sorry, a side, an angle, and a side, this is an SAS triangle. In other words, we're going to have to use cosine law. So, cosine law, again, we have two formulas. Since we're looking for a missing side, this is the one we're going to use. If we were looking for a missing angle, we'd be using this one. But this is the one we're using because we're looking for a missing side. So, let's set this one up. A squared is going to be our x squared. Let's just erase our picture because we're going to run out of room otherwise. X squared is going to equal the other two sides squared, so 80 squared plus 100 squared minus, and then the rest of the formula, 2 times b times c times cosine a. So 2 times 80 times 100 times cosine of the angle between them, which was 54 degrees. Again, like the one I did earlier, put this all in brackets. That makes it easier to put in your calculator. So putting it in your calculator, we'll go 80 squared plus 100 squared minus, in brackets, 2 times 80 times 100 times cosine 54, and close the brackets, equals 6,995. So x squared equals 6,995. But we don't want x squared, we want x, so square root both sides. You square root your answer, you're going to get 83.6. So they are 83.6 kilometers apart. And with that, we'll say that wraps up chapter number 2. Hopefully this is going to be a lot less time than that first chapter. I think it was. And so that's good.